Today we will explain our own model in which three bodies collide with each other in a box by utilizing model and sliders files. Let's learn how to work with them. In order to do this, we create a text file and refer to the methodical instructions on what the model file consists of and how it can be utilized effectively. To begin with, we set up the global section where we specify the total number of elements that need to be defined. As an example, objects, fields, gases, particles, and interactions are considered. Simply take, duplicate. We have a total of 3 individuals involved in the project, so as a result, we will end up with a total of 3 separate entities. Fields of study, various types of gases present in those fields. Particles and interactions are not required, so they will be set to 0. Next, we need to configure each object, resulting in 3 particle settings. Duplicate the numbers, starting from 0. First, we set the name, then proceed to set it again. It's important to note that particles and interactions are unnecessary and are thus assigned a value of 0. Configuring each object involves 3 specific settings for the particle. The numbers are duplicated, starting from 0. Initially, we set the name and then proceed to set it again. Let our name be P1, which is an abbreviation for the first letter of the word professional and the number 1. Electric charge. The body that we have in our possession will not be charged. Massachusetts. Assume a mass of 5 kilograms, for instance. To clarify, let's take the example of a 5 kilograms mass. At the beginning, we will be provided with the initial coordinates. For example, we will have when x is 0 and y is 50 minus 50, for example, we will also have 0. In this case, the value of x is 0 and the value of y is 0. This illustrates that when x is 0, the value of y is also 0, as indicated by the equation. Next, we take a look at the initial velocity of the object. The initial velocity along the x-axis will be 0, indicating no motion in that direction. The initial velocity will be 1 unit per second along the positive y-axis and also 0 units per second along the positive z-axis. Let's take a closer look. We need to determine the radius of the object. Let us consider that the value of our radius is equal to 5 units in length. Upcoming, image denoting texture. At this juncture, we are provided with a range of choices for textures. By default, we have a sphere texture, which means it will just appear as a sphere. If we specify a different object, like an apple, then the texture will resemble that of an apple, and the color will be the track color. For instance, instead of a sphere, we could have random numbers printed on the texture. This allows for customization and flexibility in the appearance of the texture, giving users the ability to create unique and varied visual effects for their designs. So, let's move on. Type. Type indicates the specific category or classification of the object we have in our possession. We will have it as C, that is a classical object-oriented programming language. Radiation. The object will not exhibit any radioactive characteristics or emit any form of radiation. Accordingly, it will be N, that is none. Shall we demonstrate the track? Yes, we will certainly showcase it. ShowName is used to display the name. Instead of showing the name of the display object in the 2D graphics window, we can use a plus sign to indicate the presence of a graph. Additionally, we can show the speed. However, if speed is not necessary, we can omit this information. Similarly, if the display of forces is not needed, we can exclude it as well. By utilizing ShowName, we have the flexibility to choose what information to display, making it a versatile tool for visualizing data in the 2D graphics window. Moving on, let's proceed to describe the second object. We can simply copy and paste the existing content to provide an accurate depiction of it without any modifications. Let us make a modification to the first one. Let us assign the name P2 to the new object. Furthermore, it will remain uncharged. Let's assume that its mass will be equal to 1 unit of measurement. The starting coordinates are 0, 25, 0 at the initial point of reference. At the start, the velocity will be 0 and all other quantities will also be 0 for him. The radius of the stone will be 5. We can set the stone image to accurately represent its shape and characteristics. To illustrate, let's consider this scenario. We have a stone that we can alter the color of, just like this. For instance, we can change it from blue to red or any other desired color. This serves as a prime example of the flexibility and customization options available when working with such materials. That is the way it is. Our type is also classic, just like that. No changes, all remains the same. The substance is not radioactive. Additionally, all of these settings remain exactly the same and are unchanged. Next, let's configure the third body in precisely the identical manner. For instance, there will be the name P3 as per the information provided earlier in accordance with the stated example. Charge 0, its mass will also be 1. The initial coordinates will all be zeros, and the initial velocity will also be 0. The radius is also 5. And here we will already make the picture by default with the first one. Alright, let us set the track color to 0255128, a classic non-radioactive type, and all these settings remain the same. Next, let us look at the field. We do not have space, so we need to define the space. Let us indicate that here we are configuring the space. It is crucial to ensure that all these settings remain unchanged and consistent throughout the process of configuring the track color and defining the space, as any deviations may result in undesired outcomes. This is our integration step. We set it. Let us say 0001 solution method. Let us have this one. Flag collision. Collision. This is our integration step. We set it. Let us say 0001. Solution method. Let us have this one. Flag collision. Collision. This is our integration step. We set it. Let us say 0001 solution method. Let us have this one. Flag collision. Well, we do have a collision, which is definitely a positive thing. It's an added bonus that we can consider as a plus in this situation. The speed at which the animation is displayed, the speed of the animation, well, let's set it, well, like this. I think it will be good. The scale of the axis. So let us establish a scale of 4 for each and every person participating in this. Axes, in accordance with that, are the coordinate system that is utilized for our float, which is a type of data structure. The axes we will be using are X, Y, and Z. These axes are essential for our work and provide crucial reference points in our calculations and measurements. Let's further enlarge our window. That is the manner in which it is. The position of the two-dimensional system is as such, in that particular way. We will not have any objects positioned horizontally, and we will also not have any objects positioned vertically. The number of objects in both directions will be 0. Background time-lapse. This is the background that we have selected to use for our project. However, we will not have it. It will be a black background. Let's set the background scale to 10 and position it by coordinates. This way, we can ensure the background is displayed correctly and in the desired size. By adjusting the scale and position, we can customize the background according to our preferences and create a visually appealing design. The coordinates for the background position will be set to 0, 0, 0. Moving on, let's consider the camera position, which represents the coordinates of the observation point. In order to accurately capture the scene, it is important to establish a clear understanding of the camera's location. Therefore, let us have a detailed understanding of the camera position and its corresponding coordinates for effective observation and analysis. It will be similar to 15, 20, 30, but that is not really significant because we can simply modify the camera position using the mouse. We will set the camera type to perspective, which indicates that the closer objects are, the more they will appear larger. This adjustment of camera position with the mouse allows us to easily change the perspective and enhance the visual experience. By setting the camera type to perspective, we can create a sense of depth and realism, making the objects closer to the camera appear bigger and more prominent in the scene. As they continue to go further, they gradually become smaller in size. There you go. Moving on. Displaying axes. We will proceed to show them on the screen for better visualization. We express our approval by giving a thumbs up. Additionally, we mention the color, highlighting its importance in the given context of discussion. Well, let it be like this. 255. We will not put a grid. We do not need it. The installation of a grid is unnecessary for our purposes and will not provide any additional benefits. We will merely set its color to a random value. It will not be displayed in any way, shape, or form, regardless of the circumstances. Presenting velocity vectors on the display screen for visualization. We do not need that either. Furthermore, there is no requirement for it. And the size of the vector, let's set it to 1 for example. It doesn't matter, because it will not be displayed in any case. There is absolutely no need to show off strength or demonstrate any kind of power, and correspondingly, the magnitude of certain forces. Let us also set it to 1, with no difference or variation in any way, and we will establish the ultimate disparity to be 0. As a result, we have successfully completed the setup of the space and reached our final objective. The setup we have for our box is called collision. It refers to the arrangement and configuration of the box. Here, we provide you with the minimum coordinates of the boundary of the box. These coordinates represent the lowest values for each dimension of the box. Now, we would like to know the precise location where you clicked. Please provide us with the exact coordinates of your click within the box. Your input will help us in further analysis and processing of the data. The value will be 70. It will be equal to 70. Subtracting 70 from the value will result in 0. And subtract 70. In this situation, also subtract the same amount from the total and determine the maximum values for the coordinates based on the given context and parameters. 70 along y. The measurement of 70 ounces is equivalent to the measurement of 70 units, indicating an equal amount in both cases. What will occur subsequently? Will the objects collide with the box when I toggle the switch? Yes, they will. And should the box itself be exhibited or put on display for everyone to see and admire? Let us also demonstrate that. Therefore, the configuration of the box has been fully finalized. Now let's display all of this on the graph. Alright, name x. That is the name of the x-axis. This will be, let's call it time. Name y. It will be Vy. Alright. Scale of the x-axis. Let it be 1. Scale the x-axis by a factor of 1 to adjust its scale. And then y50. Positioning of the y-axis. Rewriting the text to achieve a word count of 19 words without changing the meaning. We will have the center position and the left position in our team lineup. Let's move on. And with that, our graphics configuration is complete. And the configuration of the entire .model file is also fully completed. Save the file. Exit. Now let's change the name of the file to project.model and save the changes. We make use of the model extension in our process. It is a crucial component that helps us achieve accurate results. The model extension signifies the file format we rely on for our modeling work. Without it, our workflow would be significantly impacted, and that is the conclusion of it. The file.model is fully prepared and ready. So, let us proceed to configure the file sliders at this point in time. To achieve this, we access the instructions and note that it entails setting up the global parameters and configuring each slider individually. In the global settings, we indicate the total number of sliders that need to be specified. Let's have 3 sliders and definitely capitalize each one now, adjusting each slider like, well, any we look at needs to be given a name. Let it be a parameter that the slider affects. Let us have 3 sliders and definitely capitalize each one now, adjusting each slider like, well, any we look at needs to be given a name. Let it be a parameter that the slider affects. Let's have 3 sliders and definitely capitalize each one now, adjusting each slider like, well, any we look at needs to be given a name. Let it be a parameter that the slider affects. This will be M0, indicating that we will be exerting an influence on the mass of object P, thereby impacting its overall behavior and dynamics in the given context. The max value for sound will range from 1 to the highest possible value that can be measured on the sound scale. 100. Delta is the minimum value by which we can change the slider value. Let's say it's 0, 0.1. Okay, let's create a copy. Let's proceed to make adjustments to the settings of the second slider. It will also be known as P, but in this particular situation we will be making adjustments to its initial velocity. Consequently, the VY0 code is applicable in this particular context and situation. Once again, the minimum value will range from -5 to +5. And delta will also remain 001. And the third slider. Let us assume that we are going to make a modification to the mass of our object for the purpose of this scenario. So let's make P1, P1 here, P2, P2, P1, P1 here, P2, P2. In addition, we can set the mass range from 1 to, let's say, 10, and the delta values of 001 on this setting point slider have been successfully configured. Moving forward, let's proceed to rename our file, which we will designate as prob for convenience and clarity of reference. The project utilizes a one-point slider, which is used in this particular way for achieving the desired outcome and enhancing user experience. That is the entirety of it. Our file, slider, and module are all prepared. Now let us proceed to our constructor function. Let's write the files there, and we get the project. We can take a look. Here is our module file. Please provide it for review. Our graph, sliders. Here we raised the mass of the object by 1 unit, reduced it, increased the initial velocity, and here we increased the mass of object P2. You can play around, have fun. That's all.